Ready, set, go. Apple.
Banana.
Orange.
Rambutan.
Kiwi.
Lychee.
Tangerine.
Dragon fruit.
Banana.
I said that.
Ah, my short-term memory is trash. All right, we are.
No, it's like durian because it stinks.
Wait, what?
Durian, it's like the notoriously smelly. It's like a tropical fruit. All right, it's fine. It's like the quintessential Chinese grocery store smell. Like when you walk into a Chinese grocery store and you like smell that kind of like oh, that is a distinct aroma. It's generally durian, or like a Vietnamese grocery store. Yeah.
Huh. Is it good? Is it yummy?
It's okay.
All right, let's do this thing. This is the yes, it's Unit 5, Lesson 3 in the middle of a unit, but it is the first lesson of the second semester, at least this year, the year that 2021 when you're watching this, January 27th. So if you're watching this in 3 years, it might be in the first semester, it might be in the, you never know.
It is E-Day though.
Oh, it is E-Day. It is
for countries that do the day before the month.
I feel like most countries do, right?
Yeah.
Kind of makes sense, you know. The smallest increment of time, the next largest, and then the largest day, month, year. Anyways, we are graphing sinusoids, transformed sinusoids. So hopefully at this point, you know what a sine curve looks like. You know what a cosine curves look like. And they're really just the same thing, just with a little shift going on. We know that though, because we know that, let me just say this real quick.
Are you sharing your screen, Mr. Kirk?
I'm not. We're just, thanks for catching it. Boom. Now I am. Can you see?
Yep.
Cool. We know that sine of theta is equal to, or you know what? I want to get in the habit of it. Sine of x is equal to cosine of pi over 2 minus x. That's just like a shift. So sine and cosine are very similar, but one starts at a peak if you think of 0 as a starting point, and one starts at the midline. Speaking of midline, let's get all these vocabulary words down so we can recall them as we move forward in these two problems here, 3 sine 2x and 5 half cosine 2x minus pi over 3 minus 1. What are the vocab words that we care about when it comes to trig functions?
Well, you just said midline. So midline is the middle of the thing that's going up and down, right? So like oscillating. Right? That's the general shape of what sine and cosine curves are. So the midline is the middle. And that's the way that you can find that is just by looking at the maximum or the minimum, which is vocabulary we're familiar with.
Let me get that. Well, I'm not going to write max and min down necessarily. Well, yeah, I will.
Okay. But the max and the min, that can help us see where the midline is, because the midline is between those. And we can also get the amplitude, which is how far up and how far down off of the midline our curve is going. It's the amplitude or the height of our sinusoidal functions.
I like to think of the distance between the midline and the max. That's how I define it in my head. I could say min, arbitrarily choosing max. I think we got some more though. What do we call it when you move left and right? I guess you could say that, but we have a special word for trig functions.
Yeah, I think it's a shift, but it's also, isn't it called a phase shift?
It's called a phase shift. And I'm actually kind of curious why it's called phase shift. I don't know off the top of my head. If someone wants to figure that out and share it with us. Journal idea. Phase shift. And one last thing, and it's what this 2 does to the graph.
Well, how long is each curve going to be?
Right. We have one period.
Period.
And we've talked about that where when it starts to repeat itself. So we want to know what the period is. All right. And all of that information can be extracted from the function that we've been given. We don't need to see the graph to gain all of this information. I think the midline is a nice place to start. In fact, that is always where I start when I graph transformed trig functions. What establishes the midline, Mrs. Contreras?
The vertical shift, which in this, it seems like there's nothing being added afterwards. So we have our midline at 0, at the line y equals 0. Or for number 2, yeah, we got our our midline is shifted down one space.
So y equals 0. And I always, and you don't have to do this, but I always actually graph a dotted line where my midline is because I build my trig function using that dotted line. It's kind of like
the foundation.
Yeah. All right. How do I get the max and the min? And while I'm at it, the amplitude from our trig function.
Well, the 3 that's in the front, I think that is going to be really helpful, right? Because for our regular sine function, our maximum output is 1. If we take that and multiply it by 3, then our new maximum is going to be 3.
So I'm going to go ahead and graph that as well. I graph these boundary lines. They help me. Totally optional, but and it might be a little bit difficult if you're doing this in Kami online and you don't have a drawing pad like me. But in real life, if you're doing this on a piece of paper, you printed this out, doing that dotted line is nice. And also, actually, while I'm at it, can I get a dotted line?
Yeah, just use the line tool.
How do I make it dotted, though?
So once you drop the line, you can click on it, probably after you get the select tool, which you can press 1 to get that select tool, right? Okay. And then on the triple bar, see the triple bar? Dotted line.
Beautiful. Boom. That is information worth memorizing. Normally in math, we don't want to memorize formulas. We want to know where they come from. Here, that's worth memorizing. All right, that was silly. Anyways, all right, so we got our max, and I gave us our min. Y equals -3. But what is the amplitude?
The amplitude is how far from the midline it is to the maximum or the minimum if you're into the valley section. So that would be a 3.
Yeah. All right. We don't really have it here, but what is our phase shift? I mean, we do have a phase shift.
The phase shift is 0 because in the horizontal translation for what's happening to our input, there's nothing there.
Yeah. Maybe like 3,000 years ago, there wouldn't have been a phase shift because they didn't have the concept of 0 yet. But I'm sorry. Cool. So we have a phase shift of 0, and that's that number that's going to be right there. We don't have it here, but we do have one in number 2, so we'll see that. And then last but not least, the period. And the period is actually, I think, the most, how do I want to say this? It is the easiest to mess up because it's counterintuitive as transformations within a function are. What is that 2 telling us to do?
Like, is it going to stretch our period out, or is it going to squish it?
That's the question.
Compress.
Maybe we'll drop a question right here. Is that 2 going to stretch or compress? And the answer is?
Compress.
Compress, yeah. That 2 is going to compress. We're taking all of our outputs, and then now smaller numbers inputted into X will then be stretched by that 2 to get to the original. So we're actually going to squeeze. What is it normally? What is the period of sine without a compression?
Well, it's once around the unit circle, which is 2 pi.
2 pi. So we are now going to be, period is going to be 2 pi divided by that number, or pi.
So it's only going to take 1 pi to make the whole period.
And so what I like to do is now that I have my period, I'm going to make my scale so that I'm going to get 2 periods. Just because the prompt asks us to do 2 periods. And I like doing 2 periods because you're able to see the graph circulate twice. It gives it I don't know. One period's not enough for me, personally. All right. So if the period's pi and I want 2 complete periods, then I have a lot of options for my period. I'm going to make my scale pi over 6. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 ticks on all the graphs that we're going to give you. So this is 2 pi. That's why it's the way it is. All right, so if the period's pi, then I have no phase shift. Sine, is it starting on the midline or at a maximum?
Starting on the midline.
So we're going to have a point at 0, 0. And then after pi, I've made a full rotation. Are those the only 2 times within a period that I get to the value 0?
No, because you got to go up, hit a maximum, go down, hit a minimum, and then come back up.
So by the what calculus theorem is that?
That's the intermediate value theorem.
Yeah. So some people in their most recent project said they wanted to learn more about calculus. So there you go. All right, so that's pi over 2. And then halfway between those, we're going to get a max. Halfway between those, we're going to get a min. The symmetry is really useful. Right? Halfway between these two values, I'm at 0 again. I have a max there. I have a min there. And let's see. I graph my sine and my cosine graphs really weirdly. Don't judge me. Ready?
Oh, yeah, that makes sense. Because it's like you're doing like repeated brush strokes.
On a whiteboard, I'm pretty good about doing it in one nice swoop. But I had a little shaky hand, so I like to break it up. Makes it easier. And I could go both ways if I want. 1, 2, 3 down here. 1, 2, 3 up here. 1, 2, 3 up here. 1, 2, 3 down here. I could add more if I want, but 2 periods gives you that nice sine curve. It's kind of like Bob Ross.
Happy little sine curves.
Happy little sine curves. It's a beautiful little curve we got there.
That's a little extra though, Mr. Kirk, because it just said to do 2 complete periods and you're doing 3.
Yeah, I wanted to. Felt like it. Does it say minimum? No, whatever. Cool. All right. So let's go to a little bit more obnoxious one. But I think it's going to be fine.
Okay.
So we did a lot of things up here. Let's just talk about the midline, the amplitude, the phase shift, and the period.
Okay.
Midline.
-1. Oh, sorry.
What? No, you're good. -1. What's the amplitude?
Amplitude 5 halves.
5 halves. What is the phase shift?
5/3.
Let's talk about.
No, because we have the 2x, right? Just pi/6.
Yeah. So actually, this is a good moment to real quick. Let's talk about standard form. And I don't have to use an H. I'm going to use an H just because that's what I like, plus K. And these letters are arbitrary. All right.
Although A is nice because it's amplitude.
That is true.
I like it.
I like B too. I don't know.
Yeah.
Maybe we could use C and D if you don't like H and K, but H and K are often our horizontal and vertical transformations. Right. If you think back to our transformation unit, our functions unit, we talk about transformations. We want the inside of the function, our parent function being cosine, to have these parentheses. That allows us to see the horizontal shift, or in the case of trig graphs, the phase shift. I'm still curious why it's called phase shift. Anyways, with that said, what is the phase shift?
Well, to factor out the 2 from both parts, we got to have pi over 6 instead of pi over 3.
I always like to check my answer too. Like if I distribute the 2, I'm going to get pi over 3. I like to redistribute just to like confirm my answer. Cool. So the phase shift is?
pi/6.
Yeah. And I'm going to write a positive pi/6 just so everyone, it's very clear. Yeah, there's a negative in the function, but that negative is embedded in the standard form. We are moving to the right. We are the inside of the function transformations. They can be a little bit backwards. They are a little bit backwards. And last but not least, what is the period?
I think it's going to be pi because we have the 2, which doubles the rate.
So what I'm going to write is I'm going to write 2 pi over b, just to kind of establish that the period is 2 pi over that term. And then here, b is 2 pi.
Conveniently the same as what we had before.
Sweet. So let's get that midline, -1. Let me take advantage of our tools. Maybe it'll automatically, no, it's not. Dang. I'm going to, while I have the line tool though, I'm going to add my upper and lower bounds. 5 halves away from this. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Make sure that you pay attention to the scale. This is where We have to like insert the Jeopardy theme song. Maybe I'll do that in post. Maybe I'll get my producer to do it.
Or we can do the Kahoot music. Ding, 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 ding.
Oh, it's not doing the thing. Come on, come on.
It's been a while since we've had that.
Why is it not working?
Maybe if you do the select tool and okay, there you go.
Hey, it worked. Why did it work that time?
Because you complained. Get it? It's because I stopped singing the Kahoot music.
There we go. Cool. And I'm going to change up the color. So I'm hesitant to say where does this graph start because it has a domain of all our numbers. But when I say start, I'm thinking about where that 0.00 in the cosine function gets transformed to. So that not 0, 0, cosine, 0, 1, that peak, the beginning of the cosine curve, where does that get transformed to? I'm going to start calling that the starting point.
So it's going to be at the top, like at a maximum, but we do have a phase shift of pi over 6, plus pi over 6. So, actually, it's also nice that the period is the same because then we can keep our scale the same. But then we need to start at that pi over 6, and what is that, 3/2? Yeah.
We don't have to deal with this -1 or what else? The 5/2. We don't have to deal with those things because we've graphed these dotted lines. That's what solves that annoying problem. Now we just need to know, like, does it start at the top or in the midline, or the bottom if there's a negative in the front of the whole function.
To reflect it.
Yeah.
In the vertical.
Once we get the starting point, we're kind of home free because we're going to use the period and symmetry to get all these other points. The period is, you've established pi. So that's going to go right here. I'm going to be at the same point pi away. And I can go in both directions too.
Nice, nice.
Cool. Halfway between them, what's going to happen?
Minimum.
Minimum. This is cosine. Halfway between those.
Midline.
Midline. So I have 1, 2, 3, 4, 5, 6 dots. So 1, 2, 3. And then similarly over here, right there. And I'm going to go ahead and get these ones as well. 1, 2, 3. 1, 2, 3. 1, 2, 3. I think I made a mistake somewhere. Maybe not. 1, 2, 3. Oh, no, I didn't make a mistake. Cool. And then now I'm going to, let's see if I can do this nicely.
Nice. Good start.
Ah.
It's okay.
Oh, I was about to do it. You can't see my cursor, but I got really tempted to. There we go. Boom. And sometimes I do a little like arrow to indicate that it does continue. But now we can 2 periods. Once again, it kind of gives you a better look at what this curve is doing. Boom.
Cool.
So, I mean, there's not much else we can talk about here. I think practice makes perfect in this example, in this type of math.
Is it going to be the expectation, Mr. Kirk, that we're always going to graph these like by hand?
Not necessarily. There will be times when you will definitely want to use a computer to do this, especially when we start looking at applications of these. Or you start to think about things that are cyclic. A sine and a cosine curve might be useful to model that. What are some things that are cyclic?
Bicycles.
Tricycles, bicycles, tricycles.
Unicycles.
Anything with a wheel. If you wanna model the location on a tire, that's going to that can be modeled using a sine curve.
Oh, isn't it? There's something with that. It's like a cycloid.
A cycloid is a special curve of the position of a rock on a tire, where it is in space. Look it up, cycloid. It's cool. A very standard pre-calculus topic are tides. Tides, like when I say tide, I don't mean Tide Pods, the thing that you shouldn't eat. I mean the depth of the ocean due to the gravitational pull of the moon.
Depth of the ocean? Isn't it the height that the water reaches? Does the depth change?
I guess the depth. I guess I don't know.
Someone needs to write a journal about that.
Yeah, teach us more about tides. The I don't know.
Sunrise and sunset time, right? For the amount of daylight. That's also something that's periodic.
But it's periodic because we're dealing with a circle somewhere. Where is that circle? It's in space. It's the sun. It's the Earth. Although that's more elliptical, but still can be modeled using the circle.
Cool.
Think about it. But yeah, we will definitely be telling the calculator to do some stuff for us eventually. There you go. There you have it. How's linear algebra right now?
Hasn't started yet.
Yeah,
Great question.
But they're watching it. It has started.
That's true. Well, our first project is a recipe project. But theirs is going to be slightly more complicated because I think I'm going to make them write their recipe as a matrix.
As a what?
As a matrix. Like they have to do a multiplication.
Oh, that's obnoxious.
Is it? Or fun?
I guess it depends on how you look at it. I think we'll close this one out. I don't have anything to add.
Okay.
Cool. You want to close it out?
Sure.